Welcome to the Deep Dive. Today we're looking at a really critical intersection, artificial intelligence and sustainability.
That's right.
We know you, our listener, want to get up to speed quickly on these big evolving fields, and, well, that's our mission for this deep dive.
Yeah, we're digging into how AI's rapid growth connects with, the urgent need for sustainable practices. The aim is to pull out the main challenges and also the potential solutions, looking at what experts and industry folks are saying.
Exactly. We've got some reports here on using AI for sustainability, but also policy ideas for making the tech itself more sustainable. And, you can't really start this conversation without acknowledging the huge amount of computing power AI needs.
Mm-hmm.
The power translates directly to electricity demand, which makes finding a sustainable path, well, absolutely essential.
And the scale of that energy challenge is pretty staggering. Some forecasts suggest global electricity demand could jump maybe 50% by 2035. That is, if we don't get much more efficient.
Wow, 50%.
Yeah. And then you factor in that a lot of our electric grids are, frankly, quite old. They weren't built for the kind of intense computing AI does. So that's, a real pressure point.
Okay, let's break that down a bit, because this isn't just theoretical, right? The tech industry already uses a lot of power.
It does. About 1.7% of global emissions, roughly.
And this number is just wild. AI's computing needs are apparently doubling every 100 days or so.
It's an incredible rate of increase.
Doubling.
And if you connect that to the bigger picture, well, it gets even trickier. We're seeing this big push towards electrification everywhere. Electric cars, manufacturing, switching over.
Right.
All that puts more strain on utilities. And that makes decarbonization, which is already hard, even harder.
But it's not all doom and gloom, is it?
Yeah.
The sources do point out that while AI is energy hungry, big tech leaps often lead to better efficiency eventually.
That's a really important counterpoint, yeah. Think about early computers versus now.
Exactly. Huge difference.
And the good news is, the next wave of tech is being built with this in mind. There's definitely more awareness now that sustainability, energy use, water use has to be baked in from the start.
Okay, and the actual hardware, the chips. Our sources talk about GPUs, graphics processing units.
Right, the workhorses for a lot of AI.
And apparently for the kind of math AI does, they're just naturally more energy efficient than, say, standard CPUs.
They are, yeah. It's like using a specialized tool for a specific job, it just does it better, and often using less energy overall.
And these GPUs are getting better all the time.
Oh, absolutely. The innovation pace is incredible. Recent ones are way faster, but also use significantly less power. And looking ahead, there are things called NPUs, neural processing units, emerging.
NPUs?
Yeah, designed specifically for AI, they could cut energy use for data processing even further.
So the components are getting smarter, but where does all this happen? Which brings us to data centers.
Right, data centers. They're the absolute backbone, the critical infrastructure for all this next-gen tech. And how much energy they use depends on, well, a whole bunch of things.
Like what?
Like the building design itself, how much backup power they need, where they get their energy from, regulations, and crucially, innovation adopting new tech and practices.
Okay, this is where it gets interesting, though, because they're not just passive energy users, are they?
Not at all.
The sources say by using things like liquid cooling or even immersion cooling.
Which is basically dunking the servers in cooling fluid.
Right. And by plugging directly into renewable energy sources, they can actually shrink their footprint quite a bit and become more reliable, too.
Definitely. And the servers themselves are improving. Newer generations pack more punch with less hardware.
So smaller footprint, less power overall.
Exactly. And even smaller things like using IoT sensors and automation to fine-tune the cooling systems, that makes a difference too.
It feels a bit like AI eating its own tail, in a good way. AI is being used inside the data centers to manage energy better.
It is, yeah. Analyzing usage, automating controls, making things more efficient. So even though projections show data center energy use growing because of AI, AI itself might be key to managing that growth efficiently.
But there's a catch, isn't there? Getting the power to these massive centers.
Yeah. That's a big practical hurdle. Connecting to the grid, especially if you need new transmission lines, that can take years.
Years. And tech moves so fast.
Precisely. The sources mention this risk. By the time a new data center gets its power fully connected, the tech inside might almost be outdated.
That's a serious timing
It
mismatch.
really is, and that's why simplifying the process for connecting directly to alternative energy sources is seen as so important. Get cleaner power faster.
Okay, so we've got the power demand, the data centers. Let's flip it. How is AI actually helping make things more sustainable out in the world?
Right. This is where AI's strengths really shine. It's great at handling huge data sets, spotting patterns we might miss, optimizing resource use, basically helping decision makers in complex situations.
There's a cool example in the sources about researchers using AI to sift through decades of climate policy documents.
Yeah, trying to figure out what actually worked in reducing emissions, learning from history using data.
That's powerful. And it's not just analysis, right? It's practical stuff too, like in farming.
Oh, yeah. Agriculture is a big one. AI is driving what people call sustainable agriculture, helping farmers boost yields while using less water, less fertilizer, optimizing everything with smart tractors and sensors, precision farming.
And given climate change, AI is also playing a role in predicting risks.
A really important role. It allows for much better modeling of extreme weather, wildfires, floods, that kind of thing.
So utilities, communities, they can prepare better, be more resilient.
Exactly. Proactive risk management, better resource allocation when things go wrong. It makes a real difference.
Okay, this all leads nicely into policy. We looked at the ITI's Sustainable Technology Policy Guide.
Right, which has some concrete recommendations for building what they call a reliable, resilient, modern, green energy economy.
It seems to break down into understanding the issues and then the actual policy recommendations.
Yeah, maybe we should focus on those recommendations for building that green energy future, since that ties into everything we've discussed.
Good plan. First up, modernizing the electric grid. Why is that so central?
Well, upgrading the grid isn't just about more power, it's fundamental. You need it for data centers to run efficiently, for basic electricity security, and just to support all this sustainable tech growth during the energy transition. It connects everything.
Makes sense. And with more renewables like solar and wind coming online, the grid needs to be smarter, more flexible.
Totally. It has to handle power that isn't always on, that fluctuates, and the scale is huge. We might need millions of miles of new or upgraded power lines globally by 2040 just to connect all the planned clean energy.
Wow.
The grid's become a real bottleneck for hitting net zero goals. There's a massive queue of renewable projects just waiting to connect because grid investment hasn't kept pace.
What should governments do? What are the policy actions?
Okay, first, the guide says streamline the whole regulatory process. Planning, permitting for new transmission lines. Cut the red tape. They mention FERC in the US, the EU Action Plan for Grids. Basically, make it faster and easier to build these essential lines.
Okay. Speed up the building process. What else?
Invest heavily in R&D for a modern grid. Smart grid tech, grid-enhancing technologies, GETTs they call them.
GETTs.
Yeah, tech that helps squeeze more capacity out of the existing grid and manage the variable demand better. So more public funding, but also incentives for private investment and removing barriers so this new tech actually gets deployed. Basically, innovate the grid itself.
Got it. Modernize the grid. What's recommendation number 2?
Expand access to alternative low-carbon power sources. This is critical. We need more clean energy to meet the demand from AI and everything else and to cut our carbon footprint. Can't keep relying on fossil fuels.
And the report stresses needing a mix of sources, right? Renewables are great, but maybe not the whole answer everywhere, all the time.
Exactly. Which brings in advanced carbon-free options. Things like modern nuclear, small modular reactors, microreactors,
SMRs, yeah.
and maybe fusion energy down the line. These newer nuclear designs are seen as much safer and more flexible than the old big plants.
But those advanced techs need a lot of investment and regulatory support to get off the ground, surely.
Oh, for sure. So the policy recommendations here include governments actively backing AI-driven projects that actually help the grid use these alternative sources better.
Like using AI for better weather forecasting for solar and wind.
Exactly. Or using AI to simulate and test these advanced carbon-free technologies before building them.
And for the nuclear side specifically.
The call is for regulators, like the NRC in the US, to speed up the licensing for these advanced reactors, make it quicker and cheaper to get them approved and built, and also encouraging industry groups, alliances, focused on these carbon-free techs to accelerate development and adoption. Collaboration is key.
Makes sense. Okay. Policy area 3.
Yeah.
Resource efficiency. Where's the focus here?
Data centers again. A key place for innovation in using energy and water more efficiently. Boosting efficiency there is just essential to help balance out the increased demand from AI. Every little bit helps when you're talking that scale.
And the guide mentions specific things, like being clearer about water usage in AI models.
Yeah, more transparency on water use and
Yeah.
encouraging those advanced cooling methods we talked about, liquid cooling, immersion cooling. They're way more efficient than just blowing air around.
Right. And the final policy point was about managing the carbon life cycle.
Yeah, taking a whole life view, not just the energy the data center uses directly.
So considering the emissions from making the hardware, the supply chain, disposal, the whole shebang, cradle to grave.
Exactly. They talk about scope 1, 2, and 3 emissions. Scope 2, the emissions from bought electricity, used to be the biggest chunk for data centers.
But that's decreasing as they shift to renewables.
Right, so now the focus is shifting more towards scope 3, all those other indirect emissions in the value chain, and those can be trickier to track and manage.
We've talked a lot about AI enabling sustainability, but the sources also mention machine learning specifically. Quick refresher. What is ML and how does it fit?
Sure. Machine learning, at its heart, is about algorithms learning from data. You train a model on lots of data, and it learns to spot patterns, make predictions, classify things. It comes from stats, optimization, used everywhere now. Agriculture, climate science.
Like teaching a computer by showing it examples.
Pretty much. So when we talked about optimizing water use in farming or predicting storms, that's machine learning doing the work.
Okay. And we also mentioned it being used in data centers for efficiency.
Yep. Optimizing cooling, predicting hardware failures, managing energy loads. ML is increasingly used for that too.
And there's that interesting point about AI helping quantum computing. How does that link to sustainability?
Ugh, that's more forward-looking, but potentially huge. If AI can help make quantum computers more stable and powerful, they could revolutionize material science. That might let us discover totally new, super efficient materials for batteries, solar cells, catalysts, things that could be massive for sustainability. Still early days, though.
It's clear there's enormous potential here, but the sources also suggest it's not all straightforward, right? There are challenges.
Definitely not straightforward. I mean, the policy guide focuses on implementation for a reason. And even basic resources on ML point out limitations, things like data privacy, potential bias in algorithms, just the sheer complexity of deploying the stuff responsibly at scale.
Yeah.
Those are real hurdles.
So it really highlights that we need ongoing collaboration. Governments, industry, researchers all working together on the tough questions.
Absolutely. Questions about water use for cooling, where the materials for hardware come from, ethical considerations. These need constant attention as AI grows.
But overall, the feeling is positive, that AI can be a powerful force for good here.
I think so, yeah. The overall message seems to be that if we're thoughtful and deliberate about it, AI offers a really promising way to speed up progress on global sustainability goals, building a greener future.
Okay, so let's try and wrap this up. The key takeaways from our deep dive today seem pretty clear. AI's energy hunger means we have to focus on modernizing the grid, expanding low-carbon energy, and making data centers way more efficient.
Right. And AI itself is part of that efficiency solution, which is interesting.
It is, and policy support plus continued innovation are just non-negotiable for making this work sustainably.
Couldn't agree more.
So that leaves us with a final thought for you, the listener. Given how fast both AI and green tech are moving, what unexpected connections or maybe new challenges might pop up in the next, say, 10 years? As we try to build this sustainable future powered by intelligent systems.
Yeah, what synergies haven't we even thought of yet? Or what tricky side effects might emerge? It's such a dynamic space. It's going to require constant learning, adapting, and really thinking about the long-term consequences.